Okay, so we're going to look at Lisp, and I've already given you a tour of Lisp, and you've started on your implementation, so you understand Lisp to some degree there. And if we were to just look at programming in Lisp, that introduction I gave was probably enough for you to go to the Common Lisp manual and go and understand how Lisp works. Okay. So what's going to be different in what I'm going to talk about is that I'm going to actually talk about implementation. Okay, so let's do some Lisp programming. Okay, that's what we're going to do today. No Lisp implementation, just Lisp programming to see whether we understand Lisp well enough. Okay? And then to motivate, based on these programs, what we need to add more to Lisp than what we already have. Okay, so I might go and write a function called display. I can put symbols inside my identifiers. So I want to go and display the result of multiplying. Okay, so we already have a multiply operation, and the interpreter goes and gives you some canned output. I might want some custom output, so I'm saying custom multiply display. So I go and use what I have already, set q and lambda, to go and write this particular thing, and I can then say func call display. Again, if you're getting put off by display star result because you don't see that in Java, that is valid. You can have anything be a function name that doesn't have spaces in it. Okay, so I do func call display result 2 3, and I'll get the result is 6. Okay, so like I said, I'm doing some custom display. Okay, that's just a function I've got. Okay, so far so good. Okay, and I might later go and custom plus display also, and I can say func call display plus result. I can get the result as 5. Okay, so the result is 5 is what the function printed out, and the interpreter prints out the extra 5 afterwards. Okay, so why did I go and put these two functions? They're pretty simple functions. Nothing to learn from them, except that now I want to get into put my reusability hat on. I've got two functions, display star and display plus. Okay, I've copied and pasted the code from one to the other to create the other code. And the difference really is in the way the functions are named, of course. But the only real difference is that in one case I'm calling plus and the other case I'm calling star. So could I create a single function? Could I do reuse? How could I remove the reuse, remove the duplication here, and yet achieve the result of having a custom display of the star result and a custom display of the plus result? So I guess that you can store the result somewhere, and then do what? Then print the result. Okay, you guys get that? So, but then for every pair of arguments, I have to go and store the result, right? So I do want the flexibility to go and sum up anything and multiply anything and display it properly. So what's the difference here? Yeah.
Could you take a function as an argument?
So that's what I'm hinting here, right? That somehow the plus and star should be an argument, should be a parameter to a function, rather than hard-coded. Okay, think of generics. What do generics do? They make types as parameters, so that we don't have to go and create multiple copies of a class. And here I'm saying, let's go and create functions as parameters. Okay? So that's now, you see, so far what we've done with Lisp is, yeah, we've done recursive programming, but recursive programming is something that you could easily have done in Pascal, sorry, that was my first language, Java or other languages. And now we're getting interesting, which is also something that is not too alien to programming in C or Java. So I'll have a display result that takes not only the x and y as parameters, but also a function as a parameter. Okay? Functions are values that can be passed as parameters. And where I was doing plus xy, I'm going to do funcall fxy. Now we have fun. This is sort of fun arts. Okay, functional arguments. Okay. Questions? So I have this function display result which takes f as this argument, and I can go and say funcall display result plus 2, 3. Put on your tracing hat. Funcall plus 2, 3. Funcall is going to do what? Evaluate plus. So what should the first argument of funcall evaluate to? Evaluate to. Who was that? Very good. Please go and put down. That's excellent answer. Yes, lambda expression. Is plus bound to a lambda expression? Plus is a basic function. Okay, plus, EQ, atom, these are not lambda. Okay. So you get some garbage message. Okay, because Lisp gets totally confused. Okay, but we are there. So what should I do now? So plus is a basic function, not a symbol bound to a lambda. Okay, this is important. Questions? Okay. So I can then say, okay, we'll just define sum. We'll define a sum and a product as a lambda expression. It just calls the basic function. Okay? Because we want to pass these things around, so we could do that. Okay? Because I don't want to lose this fun art business, fun art explanation. So I'm going to take basic to lambdas. And now if I say funcall display result sum 2, 3, sum evaluates to a lambda expression. I can pass 2 and 3 to it, and I get what I want. Okay. So again, going back to assignment number 3, the first part is going to go through this. I'm just going to make you guys do steps like this. Okay. Funcall display result product 2, 3. The result is 6, 6. Okay. So does this remind you of anything you've done in 401 or even 110 like courses? Passing a function as an argument.
Sort of like map and filter.
Map and filter? So what, can you explain that to me? Where did you learn this?
I didn't take 110 here, but I know they use like filter map reduce in 110 now. So you can pass an array, and you can filter, or you can pass a function to map, like you can square all the elements or something like that.
Okay, so that term comes from Lisp called mapcar. Okay, and so that's good. So then they're doing some functional programming there, and that's good. But how about something that was not introduced as functional programming that you just had to do? Yeah.
Is it similar to passing like a class or an object that you made yourself? Like passing a class?
Passing a class to passing an object
Yeah.
to, yeah.
Sorry, this is unrelated to that, but I was wondering if we did like quote of plus, for example, would that still work because it evaluates the plus?
But you need a lambda expression finally.
We just needed the lambda expression.
Yeah. So it's just not bound to a lambda expression. So you could make a list. You could make a list with plus as being the first element, and so you could do if you do a list and you do a code plus and then pass the arguments, then that would be you can basically make a call like that. That would work. Okay, that could work in another way, not with func call, but that could be used to go and reuse.
You could do it the same way that we did it on the test.
That's what I'm saying. List.
Yeah, like something eval, list. And
Yeah, you can make a list with code. So just bypass the lambda part.
Yeah.
Yeah, that's good. I'm glad you guys are thinking this way.
So with a quote plus, and set that to A, and then I eval list A, whatever my argument is.
Right. But you're not calling funarg. Funarg will still go in.
Or you're not calling
func call.
No.
Yeah, you're not doing func call. Yeah. That's a different way of doing it. Yeah. Okay. So think of model view controller. Do you see any sort of similarity to model view controller here? There's separation of concerns. Often a model can work with multiple views, and views can work with multiple models. Okay, so you try to separate things out. Okay, so before I do that, I could have done this also, by the way. I could have just said func call, display result, lambda xy, something like that. I didn't have to go and name that function. I could have just passed the lambda expression directly to my display result without naming it as plus, as sum or product. Okay, I could have just passed this. So the important point here is lambda expression. Okay, and I get back something like this. So benefits of separating naming and definition functions. So here, what I want to bring out is that, you know, when we first did lambdas, you guys weren't motivated. I mean, why are we separating out the lambdas? Why are we creating anonymous functions? You know, the whole idea of lambda is they can create an anonymous function and name it a separate function. When would you use a body without a name? Here I'm using lambda expressions without the name. So this is the first real use of a lambda expression without its application. Normally what we've done is we've defined the lambda expression and applied it in the same line. Okay? Which is not so motivating. Here I've actually taken a lambda expression and passed it to another function that does something with it. Okay? Without having to name the lambda. Okay? And this is typically how lambda expressions are used in Java also. Like when we use the thread example, we went and passed the lambda expressions to the thread constructor because we didn't want to name that piece of code, and the thread constructor just needs a piece of code to execute. So we went and passed that. Okay, so this is sort of, like I said, showing you. I'm not saying I'm encouraging this style of programming, but at least somebody who wants to program this way, they're gaining something by not having to name this function. This is a one-time use, so we didn't name it. Okay. Let me go back to this separation of concerns, similar to MVC. So look at this F here. F is doing the computation. Okay. This particular function doesn't do any computation. This function is just doing display, which is and so think of separation of I/O and computation. And what we're doing is that this particular I/O code is oblivious to how computation is done. Separation of concerns, and we're just passing that as an argument. Okay, and I/O code reusable with different computation code. So separation of computation output at function level rather than at class level, object level. That we're keeping these two things separate. And what I was hoping some of you would say is that this is like, you guys might have heard the term callback. That callback in English means that, you know, hey, you know, you don't know me, so I go and call you, I know your number, I give you a callback number, and you can call me to finish your task. So a callback routine, typically if you build any kind of GUI, you create a text widget or something, and then you want to know when the text is entered, you give a callback object or a callback function which gets called back. Okay? And in systems, this is something called upcall, that the lower layer can call code in upper layer without really knowing anything about it, by being passed dynamically a function that it knew nothing about, which it calls. Okay? So this is not as alien as it might seem. Okay? That the whole idea of passing functions. Okay, so and just to complete this thing, I can have another display result which displays things separate in a different way. So I'm now saying result colon and using the same sum function. So we are really keeping the model and the view, or the computation and the display, separate. Okay, I'm going a little quickly. I'll review this later, but I just wanted to make this point before we. So what we're going to do today, and in the first part of the third assignment, is sort of the heavy lifting with functional programming. Okay, and I motivated some of this work by giving you first a function that prints out a result in a custom way. Okay, so rather than just relying on the interpreter to print out the result, it formats the output and says the result is. Okay, and we did that for multiplication. Okay, and we have multiplication takes two parameters. So this function takes the same parameters as multiplication does the multiplication, and then goes and does a formatted output. Okay, and then we did the same thing for plus. We wanted the same kind of format, uniformity, but we wrote a different piece of code which we just copied and pasted, and then modified, and we got the plus result. Okay, and these two functions on their own are not interesting individually, but what was more interesting was how we could get rid of the code duplication. Okay, how can we avoid copy and paste? And we saw that we could perhaps have a function that takes another function as an argument. So now we have display result, and the display result takes three parameters, not just the x and y, but also the computation to be done on x and y, and that is the f parameter. And it does a func call fxy rather than plus x plus or star of xy. Okay, so this was what we did. Any question on this so far? Okay, I'm just reviewing. So this is a fun arg. It's a functional argument, and here's how I'm calling it. So I go. So here's how I could try to call it. I could do func call display result plus 2, 3 and just pass plus directly. And so we saw there was an error when we passed plus directly. What exactly is the error?
Plus isn't a lambda. It doesn't store a lambda.
So plus is not a lambda expression. That's what we said last time. And so what exactly is going to happen when you start to evaluate display result? You're going to do func call display result. Display result is a lambda expression. And what part of our evaluator is going to encounter plus and complain? And what's going to be the exact complaint here? So when you do func call of a function, we have the first argument of func call should be a lambda expression, which it is. And then what happens to the remainder of the arguments of func call? What happens in the interpreter? What does the interpreter try to do? Yeah.
It passes those as parameters.
So it wants to pass them as parameters, but before it passes them as parameters, what does it do with them? Evaluates them. So it's going to try to evaluate 2 and 3. That will succeed, but it doesn't even reach 2 and 3. Before it reaches 2 and 3, it tries to evaluate plus. Plus is an identifier. And what does the evaluation function do for an identifier? But in general, an identifier eval does what? So no, that is when plus happens to be the first argument in a func call. That's true. If I was to do plus 2, 3, and plus was the very first element of the application, it would go to the evaluator, absolutely. But now I'm doing func call, display result. So func call is the evaluator, okay? And we expect, func call expects its first, Func call expects, in this case, display result to be a lambda expression, which it is. And what does it do with the following things? It tries to pass them as parameters to the lambda expression, and it tries to evaluate plus, and in general, identifier is evaluated by lookup. Okay, so you try to do a lookup, and there is no plus in the environment. Okay, plus is in your registry; it's not in the environment. Okay, that's what our Lisp interpreter does. Okay, so we'll get something like variable plus has no value. Okay, which is saying that, look, I went to the lookup table, I found no value. This is what Andrew's interpreter will give me. Okay. So we could try, so lookup plus fails. We could try doing this now. Try not to go and evaluate plus. Okay, and say code plus. And so now my evaluation will succeed. My code eval will return plus. Okay. And then what error will I get now? It's a little louder. Not a lambda. Exactly. Okay. So argument to func call must be lambda. Okay. So yes, we indeed made a mistake by not passing a lambda expression there. And this is sort of the error we get. This is what we get with the interpreter as we have described it in class. Okay, this is not what you get with C Lisp as it turns out, as I found out this morning when I read Ben's message. Okay, so if I try to go and pass this to C Lisp, just the plus, that does fail, but in a way that I don't understand. Okay, because we don't know what it's doing. It says print func call fxy is not a function. Okay, so it's trying to do something, and it makes some assumptions about what to expect there, and it fails. Okay, but when we go and quote, it does indeed succeed. Okay, and you guys can make your func call succeed too. You can just go and look at the next parameter, go and see if it's an identifier. If it's an identifier, do a lookup. If not, do an eval. So you could indeed, not do a lookup so much as call the basic evaluator. So you can go and because plus will not be looked up there. So you can go and actually do what the base look at the evaluator and pass it to the plus evaluator if the value exists there. Okay, so you can indeed do that, but that's not what we require you to do. So I kept telling you that the Lisp we are doing is not identical to the C Lisp for various reasons, and so there is this discrepancy. Okay, questions? Oh, and this is special handling of func call, and it's practical. Okay, and since we didn't have this thing, what we did was we said let's go and define a lambda plus, which we're calling sum. Okay, so now sum is bound to a lambda expression, and it just takes its parameters and passes them straight to the basic plus. So we are doing some work here, extra work here, and now we can go and pass sum and product to this func call, and it'll work. Okay, so we achieved our goal of reusability at the cost of having to define two different functions for the basic functions. Okay, so your assignment 3 goes through this process and requires you to do steps, make steps like this, take steps like this. Okay, questions so far? And one of the sort of confusing things when I first started on lambda expressions was that you didn't see a use for them. Okay, yes, you can type a lambda expression and you'll get back, the definition you did. That's no use. You just wrote a definition and it's printed out and we do nothing else with it later. The second alternative was we take a lambda expression and you apply it to an argument. Okay, immediately. So what's the point of having parameterized lambda if you're going to just bind those parameters to one set of arguments? Usefulness of functions comes from being able to bind different formal arguments to the same, different actual arguments to the same formal arguments. So these anonymous functions were not very motivated, but you see here now a reason for having anonymous functions. That I have something called display result. It expects the first argument to be a lambda expression. So what I will do is I will not go and define a special lambda EQ. I'll just go and pass, and I won't name it. I'll just take the lambda expression, not name it, and pass it to my display result and get back what I want. Okay? So this is a practical use. I'm not saying this is good programming. I like names associated with functions because then I know what the function is supposed to do. So it's like a comment. Okay? But if you don't want to do that naming, you just go and pass this lambda expression without a name to something that does require this as an argument, and that something is going to actually go and assign the actual arguments to its formal arguments. So you will get indeed the flexibility you want. Okay. So EQ xy returns nil, okay, because 2 and 3 are not the same, so you get the result nil. Okay, so far so good. Okay, this is, yeah.
I just want to make sure I understand. So basically the benefit is that you can avoid that problem that you had with plus where it didn't understand, it didn't look up, and now it knows. It doesn't go into any of those problems.
Okay, there are two problems. Okay, the problem is indeed what you're saying. Okay, that EQ is another basic function, and I don't have to go and define a lambda EQ. Okay, so sorry, I need to have a lambda EQ. So that's a solution, that I need a lambda expression. Once you have lambda expression, the second problem, which is the lazy person's problem, is that I know the lambda expression, I don't want to go and name it something, LEQ or something, you know. I don't want, people hate naming, okay, just as people hate commenting. And commenting, you can write some stuff and nobody will look at it later probably, but the name is there for again and again. So I'm trying to solve the primary problem of not having the basic EQ, having a basic EQ and not a lambda EQ. The secondary problem of not having to name a lambda expression, because what we expect is a lambda expression, we can pass a lambda expression directly. Okay, so this is very important. Some of your interpreters may not work any longer. If you expect the func call to be followed by a name, and you do a lookup of the name, your interpreter will fail in this. But if you indeed go and say, look, what follows func call is an expression, I will evaluate it, and I'll see whether it's a lambda expression or not, and then I will go and apply it, then it will succeed. Okay, so I know a lot of you guys were doing lookups at one time at least, and I tried to emphasize in class, this is dirty well. Okay, so this is like my the use of lambda expression in creating a thread when we looked at Java threads. That I went and just said new thread, and I just gave the body of the run method without having to define a method called run. Okay? So again, I'm not saying I'm advocating it. Part of the reason for learning much of this stuff is to understand other people's obscure code, even if you think that such code becomes obscure. Okay? So I personally don't like inner classes. I don't like lambda expressions because I want names. I want names to tell everything. My names are one paragraph long. Okay, so I want those to be descriptive. Okay? Other questions? And I want to now pop up this thing. Yeah, we're talking of our Lisp interpreter, we're talking of Lisp, but functional arguments occur in all kinds of languages. Some handle them more nicely than others. C handles them badly because you can just pass it, and Lisp also in some sense handles it badly because it doesn't even look at the header of the argument. Any function can be passed to a function that expects a function. Okay. So I want to sort of say that with functional programming, not only did we get reusability, which is the motivation we had so far, but we also get separation of concerns. Okay. And separation of concerns is that if two things are independent of each other, that means one can change without changing the other. Let's go and put them in different constructs. Okay? In object-oriented languages, we talk of different classes. If we don't have different classes, let's at least put them in different methods or procedures. So, and the particular concern we have right now is computation and I/O. Okay, now there are two viewpoints. One says that computation should be one unit, and input and output should be together, one cohesive unit. And the Smalltalk idea which says input should be separate, output should be separate, and computation should be separate. Okay, so two levels there. So here I'm sort of combining the input and output, and my display result is just, it's like the controller too, it's calling the function, plus it's displaying the results. So it's doing both the controller and view job, but it's not doing any computation, okay? And it's not hardwired to a computation. The computation is something that's a parameter to this, and the same view, if you will, or the same I/O can be used with different functions, different computations, okay? That's what we have here. Display result can be used with a computation that sums, and display result can be used with a computation that multiplies. It is oblivious, it's ignorant, unaware of the exact computation. Okay? So I'm just trying to drive that point that that's one reason for having functions as arguments. Okay? And not only that, so we have same I/O, two different computations. So I lost the recording there. So I used last time the term callback and upcall for a function parameter being for a function parameter. And we kind of motivated callback at least. So why is a function parameter called a callback?
It's because once you basically like the first order of calls, so like you call your first function and call back, you'll notify that and you'll call that.
Okay, so that's good. You call the first function and that goes and calls the parameter, right? Why don't we just say it's a call? Why do we say it's a callback? It is a form of call, right? So why do we go and qualify the call as a callback? I mean, in the English language, we use the word callback, right? Yeah. You can call back to? Right. You can call back. So why? Yeah. So it's calling that function. So why is it calling back again? I think you're saying the answer, but I'm not quite hearing it. Yeah, it will call the product function if the product function is being passed. Yeah. It can return something, but all functions in Lisp return something. Andrew? Sorry.
You gave it the address of the function to call.
You gave it the address. Okay. So the point is that in the English language, what do we say? I leave a message on your answering machine and say, call me back. And here's my number. You get a junk call, right? You don't know about them. They know about you, unfortunately. And they leave a number. You know, FBI is after you. Call back. So you may or may not do that. But so that's the unaware. Okay. And why would you call it an upcall? Why would you? So I'm saying it's also it's called callback. It's also called from a software engineering point of view in some contexts. Okay, and somebody else want to raise your hand before I. Why would you call it upcall? And what is the word up and down going to be relative to? Okay, Mac.
Maybe the stack.
Stack. Okay, so that's good. That's a layered thing. But stack is a dynamic thing. Think of something that's got these levels at program writing time. Yeah. Higher than the memory location, but virtual memory or physical memory? It reminds me of Monty Python. African seagull or European seagull? Either way, you should be quite oblivious of where memory is, especially if everything is in the heap, you just don't know what's going to be there. So, but indeed, higher virtual memory is code and data. But think software engineering. I'll take Nathan, but Nathan, okay, Nathan.
Okay, well, I don't know. I think it's because if I'm listing up the functions in like a tree style, you would like open the function, see what's in it. But it's calling a function that would be higher in the tree. So it's like if you think about like tabbing, that it's calling a function of a different like area. Is that sort of makes sense?
So that's kind of the answer we got earlier about stack.
Okay.
Okay, so the stack is sort of the dynamic chain.
Yeah.
But in software engineering,
So in operating system, the kernel should be under the client code. So when you say upcall, it should be the kernel calling client code.
excellent. Okay, so the kernel is something given to you, and the code on top of it relies on the kernel, so it's called layering. It's not just operating system. If you're doing networking, there's 7 layers, 3 layers, 4 layers, who knows, depending on whose religion you're following. And but in general, there's this notion of layering. That code that runs on top of the kernel knows about the kernel. The kernel does not know anything about the code that runs on top. If you want the kernel to go and call something in your code, then that code will be an upcall. It's a very dangerous thing to do. I've seen many operating systems designed that way. Why is it dangerous to have upcalls in a kernel? Privilege escalation. I mean, if your code goes in, just has an infinite loop, nothing else. Okay, your kernel's gone into an infinite loop. Okay, so what they do typically is that if you're allowing upcalls in the kernel, and there was a PhD student whose committee I was on who did this, they try to define a safe language, which is not Turing complete, which can allow you to do that kind of upcall. Okay, but when you do when you call an interrupt routine, then some lower level part of the kernel calls a higher level layer of the kernel. So there is that kind of stuff. So let's talk of layering, software engineering. So we talk about separation of concerns. Let's go and separate things out. A stronger condition is that these concerns should be layered. And what does it mean for, I've kind of said it, but let's go and define it formally. What does it mean for some layer to be above another layer? I mean, I can just draw it above. Is there a litmus test to figure out that this layer is on top of this layer, and this layer is below this layer? Yeah.
I was just thinking maybe the layer below it has a different scope compared to the layer above it.
It's got a different scope. That's true in some sense, in a very general sense.
One layer uses another one that has to be above it or above the one it's using.
So if it knows about them, okay. So when you have classes, all classes are basically at the same scope. Okay. The question is, do you know about those classes? Are you linked to them or not? Okay. So a layer above, the higher level layer, uses the functionality of the layer below. It knows the interfaces below it. So when you're writing that higher level layer, you know about the layers below. You can import something from a lower layer. A lower layer can't import from you. So Andrew's Lisp interpreter can't import your code. It doesn't even know what you've written. Your code can import Andrew's code. Okay? Application program can call kernel routines. That's a standard API. The kernel can't call your routines. It doesn't even know who you are, whether you'll ever exist. Okay? So that's layering. And then there's 2 kinds of layering. Can you only call the routines immediately below you, or can you also call your descendant, or I'm calling the descendant, but layers that are not immediately below you? Okay? So the calls can occur to the layers below you, but upcalls can occur the other way around. Okay, so the upper layer can go and say, here's a function, and please call it. You don't even know what that function is, but you call it, and you've been told about it through some dynamic system. Okay, so calls known as program writing time, where the caller is aware of callee, and the signature of call is defined by the callee. The kernel defines its API, not the not the application program. Okay? Andrew defined his API, not you guys. Okay? And you went and called his routines. So if this is what calls are, what are callbacks? Are they known at program writing time? No, right? So signature is defined by who? So in a down call, it's defined by the callee. In an up call, it will be defined by? Because the lower level layer doesn't know what signatures you will invent. It defines the signature. It says, here's the signature I understand. I don't know what the implementation will be, but you better send me a two argument function, and I'll call it. Whether it be product, whether it be sum, I don't know, but it's a 2-argument function. Okay? So it's known at execution time. The exact code is known at execution time. The caller is unaware of callee, and signature of callback defined by caller. Okay? Even in calls, with object-oriented programming, it becomes a little tricky because the signature at, the calls are known at program time. There exists an object of this type that will actually go and execute it, but you don't know which specific type will be used and which implementation will be used because dynamic dispatch. So dynamic dispatch makes things a little confusing with the caller thing, but in a language like Lisp or C, it's more clear that there is no dynamic aspects in calls. Okay? Questions? Okay. So your Lisp interpreter skeleton and your customized interpreter have this callback kind of result. And this is important because in our system we wrote the Lisp interpreter in Java. So we used Java's mechanisms to go and extend it. Had Andrew or I, whoever, written the Lisp interpreter in C or Lisp, then if I ask you the same question as I asked in the exam, what capabilities are used to extend it, you would say upcalls or you would say function parameters. Okay? So had we not had dynamic dispatch and interfaces, and had we relied on a different kind of Lisp interpreter, then we would have had used different mechanisms to extend. Yeah. Header. So header files is a form of interfaces. Indeed. But you would still have to pass the functions to the Lisp interpreter at runtime. You can say, here's my functions. It would not be very type safe, okay, but it could be made to work. So like I said, if rules had changed, then the answer would have changed too, because upcalls would give you the same kind of customization, extension flexibility. Okay? Questions? Can you see a connection between the distributed server client and, I'm kind of showing you the connection. So why is interaction with the server a call-like thing, and why is the interaction between the server and the client an upcall-like thing? Oh, were you raising your hand?
Yeah.
Oh, I wasn't sure whether your pen was up or not.
Yeah. Servers are known in name and clients are not known.
So servers are known. That's what we said. If there are two processes, they're talking to each other, which is the server, which is the client. And we talked of one to many, many to one kind of things. And when I taught distributed system, one student said one is a dumb thing and one is a smart thing. And basically, it is a layering. The client knows about the server. Okay? Sends its host and port to the server. When it does a connect, it says, here's my host and port. Okay, this is all done underneath. You don't really see it. and then the server calls back or sends messages based on what was sent at runtime. So the same general principle, if you will. They don't call it up calls and calls, but if you think about it abstractly enough, that's what's going on. Okay, and server came first, so that's what you're layering yourself on. The client depends on the server. The server doesn't depend on what was written in the client. In fact, a lot of times people go and replace kernels. So when you want distributed operating systems, you make the kernel be a distributed agent. Okay, so that you can make API calls essentially to another computer. Okay, so these are very related concepts. Okay. Questions? Okay. So let's look at what we had. Okay, we started the display result that was kind of bound to plus. Then we came to a display result that took the function as a parameter. Okay, and what we ended, we were duplicating code. That's bad, of course, but the call was easy. We could just have 2 parameters, whereas now we have to pass 3 parameters. Okay, but it's reusable. So can I write a reusable piece of code or reusing code that takes 2 parameters? So can we rewrite display plus result to, and this is not a very subtle question, but I'm trying to lead to something else, to sort of have the reuse capability and have to have exactly 2 parameters? So can we combine these 2 things together, reuse and 2 parameters? I mean, how can we, is the question.
You have like the first parameter being whatever function you're using, and the second parameter being a list of the arguments.
So yes, you're right. Okay, let's look at the number of things I enter. Okay, you just made me say list also. So I'm happy to define a new function. I just want reuse. Reuse is not meant for, and I'm going to pick on Chris here. So reuse is not meant to save you typing. I want to remind you right at the beginning, when reuse is to make sure that when you change, you don't have inconsistent pieces of code. So I am willing to type as much as you want me to type, but I just don't want to go and have inconsistency. So I want a function with 2 parameters. Okay. But I don't want inconsistency. So what would I do? One is to define a new display plus result that takes this list and this. Otherwise, I can define a new display plus result that does what? I mean, yeah, this is not too subtle, so I'll just go away. Really? I mean, so define display plus result. Okay, let me put it more concretely. Define display plus result in terms of display result. Can I do that? Not too hard, was it too simple to answer? So I just take 2 parameters and just go and do a call, I just pass that function there. Okay. So these 2 things don't have to, and I kind of make you go through this process in your assignment 3. Yeah.
I think there's just like typos in the call to display result. Usually X and Y, not 2 and 3.
Oh, sorry. I wonder. I did try to run this stuff, but yeah, I just decided to hardwire everything. Yes, I copied this call display results on 2, 3 onto that. You're right. So it was hard to write.
These are also assuming you redefine some, right? Yeah. Okay.
I didn't redefine sum. I defined sum. Plus became sum. Yeah.
Oh, okay.
Plus was the basic function, sum is my lambda function.
Did you type that in as a set use
Yes.
lamp? Okay.
Yeah. That was way back, 5-10 slides away. Okay. So, okay. So guys, I may or may not correct this, but just be aware there's a typo there. Okay. The joy is, at least I'm not inconsistent. So, copy and paste is great for PowerPoint at least. Okay. Almost every time I copy and paste and don't run it, I make a mistake. So that's why I like typed languages. Okay, my mind wanders. Okay. Now, when I was talking about this last time, I was very pleased actually. The 3 or 4 of you said, "Can't we use quote plus?" And Ben told us how we could use quote plus in C Lisp. So we can't quite do it in R Lisp, but I want to use quote plus, and I'm willing to define a new quote R display result. Okay, so rather than display result, it's a display result that takes a quote arg. Okay, so you see how I'm using it, that I'm passing quote plus, and I want this result. So the puzzle is, how would you define quote arg plus? And actually there was 2 or 3 of you who last time gave me the answer, and I don't see at least one of them right now. But Chris, you gave the answer last time after class. So, or anybody else want to say how would quote arg plus work? Nathan? Same thing we did in the test. That's what a couple of you said in the thing. Same thing. So I told you that every exam I want you guys to learn something new. If you learn and apply it too, I mean, that's great. So I can do a print list. I can create a list with that function, okay, and eval that. Okay. So this is the kind of way you would do it in Java, or sometimes you would just take code and compile it, and this is kind of what you're doing here. So this is using the fact that functions and data structures are, the homo iconicity of Lisp. We're really using this here. That function calls our lists, and we're just creating a list that is then evaluated. Okay? Matt, you have a question?
Just it's just kind of confusing how eval list. I guess it just works there because it's just plus, or like just the single token.
I did a quote plus, right?
Right. Yeah.
So the plus never got evaluated. Then I created a list whose first argument happens to be plus, and second, the other 2 arguments are evaluated to whatever x and y evaluated to. Then I call eval. Eval will evaluate the list, and that will be used as a function call. So there we go. Just exactly what we did in the exam. Yeah.
I'm just curious because I'm trying to think through how this would happen. What happens if you just put f, x, y in this scenario where you have 12 plus? Because that would turn into an identifier.
Sorry, hang on. Where?
Data structure looking like plus x and y, and then it's evaluating it when you do print, or is that why we need to kind of list, or what would happen?
You want to create a list out of that, right? We want to pass to eval a list that consists of these 3 elements.
Yeah.
If we do eval fxy,
No, not eval list, just fxy. Just print parentheses fxy. What happens?
so what will happen? Let's go and see. F will get evaluated to quote, x will get evaluated to whatever, okay? And print will get,
Identifier out of plus x y, or would it not get the y?
so print will try to evaluate So your what print, the evaluator will be called, and that's got the tail. So that's a list within a list, and you'll have to, I think your evaluator will, so the print expects a single argument. It'll get a single argument, and it'll eval that.
Would it be F is not a
So it depends on what Andrew gives you there. So,
Would it be F is not a valid evaluator because it thinks that we're trying to call like a function named F at the moment?
yeah, but that's different. That's a separate issue. But because in this case, X and Y are already evaluated. Normally, you want to say list because you want to go and evaluate the arguments.
Yeah.
Okay? So your print evaluator has your tail. So
Tail consists of that. Well, tail consists of parentheses, quote, plus, parentheses, 2 and 3, or X and Y. And so then it evaluates the quote, say identifier M plus, and then the print evaluates identifier M plus 2, 3.
no, but hang on.
Yeah.
The list that you got was X, Y.
Sorry,
The one Andrew gave you had X and Y in it. We never went and replaced that with the X and Y that was passed to it.
But if it evaluates the plus, it's going to look at its tail and look up X to be 2 and look up Y, because if you are evaluating the plus part, it's like
I'm just wondering whether there's an extra list around it.
yeah.
Because print will take its argument, eval it, and there it will. So where did F get replaced by plus then?
I feel like if it tries to
Where did F get replaced by plus?
to the point,
Because print just expects its arguments, right? It's got a list, it's got raw data. This is what Andrew gives you. He's not done anything there. So where did the F get replaced by plus? You have to evaluate those elements somehow. X and Y, if we could somehow make that become plus, then X and Y will get evaluated. But print never got, the F never got replaced. So it will look up the evaluator for F and not plus. But the interesting thing is, you can just run it in an interpreter and see what happens. But I think that's the right answer. Okay? Questions? So do you guys get that? Instead of saying list fxy, if you just put fxy there, what would happen? Okay? And that would be a sublist that Andrew has created. You cannot evaluate that. That sublist will then go and look up the first argument, go and see whether it is something you can look up. F doesn't happen to have a value, so it'll go and just give you that error. So you somehow want F to be evaluated, and X and Y have already been evaluated. And if it was calling that particular plus, then X and Y indeed would get evaluated and looked up. Okay? Questions? See, this is why you need formality, okay, to answer questions like this. Either you need to sort of prove something, or you need to go and have an implementation. In fact, implementation is it's not a mathematical, but it's a precise definition of something. Yeah.
I've seen the code class is trying to assign value from the Lambda expression arguments. And at that point, the F should already be plus. And the difference in using values or just the fx level.
So you're saying F is already bound in the current environment, And when you go and do fx, then it will have to be func call, right? Because f happens to be, oh, sorry, f has to be plus. So f is, if you're saying f is in your environment. So, but we don't expect pluses to be in the environment, right? We expect plus to be a basic function. Plus has got no lambda expression associated with it. We want the evaluator of plus to be used.
So plus here will just be a identifier, and the f in the environment will refer to the plus identifier.
No, so the thing is this. When we go and call a function, f cannot be, when we just say fx, some function called fxy, f is never evaluated. Func call f is evaluated. If you say func call f, then that f is evaluated. If you just say fxy, f is never evaluated. You go and look for an evaluator for it. F is in your environment, but it is not in your evaluator registry. But I'm dying to sort of go and see what happens in the code. Okay, but I suspect that's what's going to happen.
Because when you're evaluating a lambda expression, which is already value assigned.
So just remember, right now, we have two ways to call functions. Okay, we can say func call f, where f is bound to a lambda expression. Or we can just say f, without func call. We haven't done defun so far in our interpreter. If we just do f, it looks up in the environment for a lambda expression. Sorry, if you do func call f, it looks up the lambda expression. If we just do f, it looks for an evaluator named f. And there is no evaluator of f. Okay? Okay, but this is good. Okay. So could I do this? Now that I have that code, can I say code sum?
No, for the same reason we just talked about. Because then it looks for the sum for the
Because this is not a func call.
sum evaluator.
Okay, so undefined function sum. Okay, it looks for an evaluator with sum, and it doesn't get it. Okay. So we have to remember that basic function and lambda expressions are two different things. Okay, and when we do defun, it'll kind of mix them together, but defun also expects lambda expressions.
So when we did O plus, is that this phone call just treats as a lambda?
Sorry.
This phone call treats O plus as a lambda expression.
Yeah, so in our interpreter, we can't say func call plus. In Ben's interpreter, you can. In C Lisp, you can. But in our interpreter, you can't say func call plus. Okay? We always expect that to be lambda expression. That's more uniform. It's not very practical. You can do special casing and say, oh, if that happens to be a basic function, I'll do the basic function thing. Okay? Okay, so we've seen that we can reuse code in two different ways. Okay, we can have we can have something that is a lambda expression or something that's quoted. So we can do a func call. It should really be. So I don't know what to call them because I'm calling it funarg versus quote. So by the way, given these two ways of doing things, forget the fact that plus, assume that we've got a C Lisp-like or Ben-like thing. Which do you think is better way to code? So forget the fact that you can't, sum and plus are kind of not interchangeable right now. For now, just conceptually, from understanding the code, which to you is more understandable? Chris, which one? The first one, the second one? Why?
Just because it tells you what you're doing some.
And you're doing func call. It tells you you're doing a func call. Okay? Whereas here you're building up a list and you're evaluating it, and and think about it, that supposing you had a programming environment that actually gave you help with filling in the syntax. By telling it you're doing a func call, it can go and make sure that you're doing certain things. If you just say eval list, it doesn't know what kind that list is supposed to be. Okay, it happens to be a func call there. So probably that first one. Okay. Can we do it a third way, whether we like it or not? I mean, it's good to go and understand all the obscure ways, like I said, also because somebody might use an obscure way. Can we somehow do reuse with function return somewhere here too? Can we bring in function returns, and actually the reuse is occurring? Yeah, let's go and just see how can function return somehow play a role here. Yeah, I don't know either. I haven't provided the full motivation. I want to use function return somewhere in this problem. Okay, I want reuse there. So let me I don't have the right slide, but remember how we define display plus result in terms of the funart display result. Remember that, where I made a mistake of 2, 3, and xy. I don't want to do that. I want to have an alternative to not these two things, but an alternative to the display plus result that involves a function return somehow. So that function, display plus result, called my display result, right? It went and called in its body. And I want to go and somehow generate that function, display plus result, as a function return. And I might just have to sort of give you this answer, because I try to make everything I say something derivable from a question, but even when I'm making the slide, I wasn't sure. But anybody want to think about somehow? Yeah.
You use like column to test the code to see if it's plus.
No, I want to somehow get function returns here. I want to build something that will return a function that I can then call to do the sum. That's my thing. And I want it to be reusing. So, but I want to generate a function that I then go and call to get the sum. That's what I want to do. You can nest it.
So you have like set Q arbitrary function does set Q all this stuff and then returns
A little simpler than that. I have a generator, and we're going to play with this a little later when we do currying to make this more motivated. But this is something we can do right now, which we can't, the currying stuff we can't do right now. I have generated a sum function, display sum function. So this function takes how many parameters? The function that I'm just showing you. We are nesting, like Nathan was suggesting. I'm returning a function. Okay. So there is the function that I'm defining, and there's the function I'm returning. The function I'm defining takes how many parameters? 0. The function I'm returning takes how many parameters? 2. So the function I'm generating does what? It does the display result sum xy. So I've generated a summer, display summer, rather than just going and hardwiring that. And later we'll see that we can actually pass a parameter to this top function to make this more modular. So I can go and say func call. So there are 2 levels of func calls. I first do a func call to get the function. And once I've got the function, I go and then call the return function with arguments.
This is assuming some has already been defined.
Yeah. So this is not that motivated right now, okay, and we'll motivate it later. There's a guy called Haskell Curry, after whom the language Haskell was invented, named, and the Curry was used to, he loved to return functions, and we'll go and look at the Curry operator later to sort of make this more useful. But you see at least what I'm doing. I have a lambda. I have a function that returns a function.
Based on your inputs. Like if you wanted to set a specific variable, but you want the variable name to be dynamic, which a lot of languages can't do actually. So, you want the variable name to set things to be dynamic. You can make a function, make the function that sets things.
So, and I do this kind of stuff in Java too, by the way, believe it or not. I take Java, I take a piece of code, I generate a piece of code based on my current state, I compile it and I run it. Okay? So it's a little bit more awkward in Java, but this facility is, you have a lot of generators in this world. So that's the function. So again, let's make it very clear what's happening. I have a function that takes no parameters, and it goes and returns a lambda expression, not an application of a lambda expression. What we saw in the previous func display plus result, it was that there was a lambda expression that went and applied a function in its body. Here we just return the lambda expression, which takes two parameters. We don't apply it. Okay, again, I'm trying to show you how we can use anonymous lambda expressions. And then the idea is that once a lambda expression is returned, I'll go and pass it parameters. So I do the inner func call to first get the function, and that's why I'm calling it a generator, and then I'm doing the outer func call to apply these arguments to the lambda expression that was returned. Okay, and this will all become much more concrete if right after this class or today you go and do assignment 3. Okay, this is the time to do assignment 3 first part. Everything is fresh in your head. Consolidate that, and you learn some of the deepest things in functional programming. Okay, and what I could then do is I could also do something like this. That I take the return function, assign it to a variable function. Okay, so that I don't have to go and do this nested func call each time, and I can then just keep applying this return value again and again. This is what Lisp was invented for, to actually generate programs at runtime that learn things. Okay, it was not all this machine learning thing where it's all done through statistics. The idea was you were generating code at runtime by learning things. Okay, so you actually generated this particular function, and you've gone and then stored it in a variable. Okay, homoiconicity, and then just do a func call on that, and you've got this. Okay, so this is all that you need to do this first part of the assignment is in front of you. Yeah.
So for the first one, the inner func call we're using from that one is not a lambda by itself.
Yeah, the func call it returns a lambda. We don't give it any arguments, right? So that func call returns a lambda expression, which I'm then passing to the outer func call. The inner func call returns a lambda expression. The inner, remember so what was outer? The outer lambda is the inner func call. That's the confusing part. The outer lambda in the definition becomes the inner func call, and the inner lambda in the definition becomes the outer thing because we're returning things. So this func call, returns this lambda expression. And to this lambda expression takes x and y, to which I'm passing 2 and 3. And I'm doing this in gentler steps here. I'm saying generated sum and display result is assigned to it funcall this. So I get this lambda expression stored here, and then I say funcall generated 2, 3, which is just saying this in 2 different steps. That's what you expect from return functions, right? You return a function, and then the return function can be applied. So one funcall to return the function, one funcall to go and call the return function. Yeah.
So I know this is sort of like a question that's sort of like ahead of the point of where we are, but I'm sort of curious if everything has a critical at this point in time. We're using SetQ a lot. Why? I know we don't know how like defun really works yet, but why do people use SetQ over defun? Is one of them inherently better, or like, because if you're building like a coding style and you use a lot of SetQs, then you can fun somewhere.
Okay, so what are defuns and why are defuns? And I didn't even know about defuns when I was studying Lisp. Okay, so I very carefully try to layer Lisp, since I believe in layering, and you'll see how carefully everything is done. So defun will use setq and will be conceptually use setq and some other concept we're going to look at, and then it creates a different namespace. So it does 2 or 3 things differently. But we are gently going towards it, but we don't need defun right now. Okay, we need something else, which we'll come to next. There's one more thing we need before we can really use return functions. So there's a reason I can't do currying right now, because there's one very important thing that there was discussion at Piazza on about, which we haven't done. No, that's set. I hate setQs. So as you should, you want to have as few setQs as possible, and you want to have setQs only of functions in the good old Lisp, okay, the functional Lisp. So later with curry operator, fun result will be better motivated, but this is what we're seeing here is fun result. So at least you guys, and by the way, if you do C programming, you can return addresses in C, right, and use them. In C programming, you'll see a lot of stuff like this. Okay, so it's very important to sort of understand this concept. But what type safety do you have here? Except that you will get an error rather than code dump. Right? So yes, having programmed in C and Lisp both, Lisp was more friendly. But Lisp also is, as you've seen, you better not make a mistake in Lisp either. Okay, questions? So the term higher order function is often used. And can somebody want to define what a higher order function might be? Well, that here's a term, here's something we've learned. Try to fit the term to something we've learned. Andrew? Function that returns a function. That could be one definition. And somebody want to have an alternate definition? If it uses a function, then if push stack uses array.lists, that's not quite the same thing. Uses a function if expand on that. It has a function argument. Okay, and if you actually go the argument thing, you can get a first order function is function that takes no function argument. Second order function is a function that takes a first order function as an argument. Nth order function is one that takes n minus 1 function argument. Okay? So function whose arg or return value is a function, and it could be a name, it could be an address in C, or it could be a lambda expression. That's a secondary thing, but it's basically a function that manipulates functions, essentially. Okay? And real functional programming involves higher order functions. Yeah, it's like a class using another class. Yeah. Okay. So let's come to kind of Nathan's question. What are we missing? I mean, forget this define. Define lets you go and not have func call. And with func call, we know that we can take the f and it be evaluated, which is a very nice feature. What do you think is really missing so far in what we've done? Something fundamental, conceptual. And there was a Piazza discussion on this aspect, actually. Nathan? Yeah, let's not change global variables. I hate them. Okay, let's look at functional programming. Yeah, scopes. Scopes, you can have more scopes. Okay, so there's something called let that allows you to have more scopes than just two scopes, just more static scope. Yeah, I'm kind of giving the answer away here. So there was a discussion, there was a question asked on Piazza, and Ben and Tao, is Tao here? They got into a discussion on, they gave an answer, and I don't know who Tao is, but there was a guy called Tao who also was involved in the discussion. And it has to do with scoping. So there is, when you return functions, the question is what is the scope of the function? Okay. And there was a discussion and people talked about lexical scope. Okay, so what assignment 3 part 1 is about, and what we considered in the last couple of lectures, I guess, is higher order functions. And we said a higher order function is a function whose argument or result is another function. Okay, and we saw 3 kinds of higher order functions. 2 of them that take function parameters and 1 that returns a function. And we saw we could write a funarg function either using a direct function parameter, which either does a func call or does an eval. And when you do an eval, you can just go and pass directly basic functions. And when you do a func call, you have to pass lambda expressions. Okay, so the first one does an eval. So you say print eval, you create a list that describes the function call, and you eval the list. Okay, and in the second one, we just do a print func call fxy directly. Okay, we saw the details last time, and at that point, Nathan said, why do we really need to do list fxy in the first piece of code? Why not just do fxy? Okay, and no eval. And I said, look, we won't find the function evaluate. And so just, I verified that in our implementation. So just did print fxy. And indeed, f is bound to plus, x is bound to 2. And so that environment is indeed set as Ruben had pointed out last time. But the evaluator for f is called, the system tries to call the evaluator for f, and that doesn't look at the environment, looks at the registered evaluators, and there is no registered evaluator for f. Okay, and we can try to do that in Common Lisp. In Common Lisp, since it has func call, it looks at the evaluator registry and it looks at the func call registry, which we haven't done so far, but there is a registry like that. And it says, sorry, there is no func call. There's no function defined. Sorry. So Lisp supports defun. I didn't mean func call. It supports defun, and we haven't done defun so far. And it looks at the defun table, which we haven't done, and doesn't find f in the defun table either. Okay. So that was just a little detail. Questions on this?